Okay, so this is chapter 10. As we start into chapter 10, we're really talking about looking for the relationship between x and y values, or between two data samples. We'll typically call them x and y. And it really has to do with the question of whether or not there's a linear relationship between them. You know, if x goes up, does y go up in a pattern that looks linear? We want to know what kind of relationship exists between those. We call them independent and dependent variables. Scatter plot is something that's a useful way for us to visualize the relationship. The more a scatter plot looks linear, the more confident we can be that, yes, we should be running a statistical test here. And we can see on this example here, hours of study versus test scores, that yeah, as you study, your test scores tend to go up. That might include, you know, in-class time, but it's that amount of time that you spend on a topic before you test, and the way that you would test there. You know, there are two different statistics that we're going to work off of. The first is the population correlation coefficient. Remember, for our population values, we use Greek letters. It looks like a P, but really it's the Greek letter rho, which looks more like that. The Greek letter rho is going to represent the hypothesized correlation coefficient, and what we expect the relationship to be amongst those variables. And this is just how strongly are they related to a linear relationship. Whereas the sample correlation coefficient, the thing that we actually test, is called R. It's the sample correlation coefficient, and its value will range somewhere between -1 and 1. 0 would represent no relationship, a -1 would be a very negative relationship, and a +1 would be a very positive relationship. We, in this course, use the PPMC, the Pearson Product Moment Correlation Coefficient, which is calculated by this formula that you won't use because we'll use a regression test on our TI-84 calculators, which allow us to do that test without doing the specific calculations. When we need to find that correlation coefficient on a TI-84, first thing we need to do is we need to go and find how to turn on the stat diagnostics. There's a couple of different ways, and you can see them here. One is to press stat, one is to go into the catalog. The catalog on your calculator is in the 0 function, but it's second and 0. And then here's our catalog. If we went down to diagnostics, which is D, notice it's on alpha. I can select letter D, it'll bring me down to the D's, and then just kind of slide down. Diagnostics on, diagnostics off. And so you turn it on. The other option is to press hit mode and scroll down. You can see right here, stat diagnostics on versus off. We need that on. And then we just put our data into edit and do L1 and L2. If L1 has your X values and L2 has your Y values, you're ready to go. The regression that we run in the calculation option is this linreg option 4. And if we come down here, we can see the R value posted for that data set. And so that's what we can use to find our R value. The closer it is to -1 or 1, the stronger the linear relationship. You can see 0.5 is here, 0.9, and then we get that really solid relationship at 1. If it's negative, it just means it's trending downward. An R value of 0 means that it's completely random. The way we perform a correlation test, we'll use table I out of the textbook, which I will have to pull up for you here in a second. But we start by drawing a scatter plot, and yes, you should always draw a scatter plot. Then we're to compute the value of the sample correlation coefficient, the R, using our calculator. There's a set of hypotheses that we will write. They'll always be the same. And then we test the significance at either 0.01 or 0.05 using table I. Give a brief explanation of the type of relationship. If you're not handed an alpha value to use the 0.05. It's less restrictive. It's sort of like you're accepting a linear relationship maybe earlier than you should, but if we don't have a reason to say 0.01, we'll go with 0.05 as our default. When using the critical values, remember that if the R value does not fall beyond the critical value, we do not reject H naught. So basically, there's going to be a cut line on both sides because the critical value okay, will be positive and negative, and then your R value will either land closer to -1 or closer to +1 or closer to 0. Anywhere in here, in this middle bubble, we do not reject. The evidence is not strong enough. But when we get out on the tails, it is significant. And for table I that we'll look at in a minute, the degrees of freedom is n minus 2. All right, let's keep rolling. Our hypothesis statements will always be the same. Remember, this is the Greek letter rho. This is that population correlation coefficient. Our null hypothesis is always that there is no linear relationship. So the population correlation coefficient equals 0. The alternate is that it doesn't equal 0. If it doesn't equal 0, it means that there is a linear relationship and that can, and a model, an equation that can model the relationship. And so, that's a summary that we'll put at the end of it. It's based on whether we reject H naught or not. Okay. All right. Compute the value. So we're going to go ahead and run through an example test on this question here. All right. So stat. Let's go to edit. First thing I want to do is actually put these numbers in. You can see I have some of them already in, but I need to put in the rest. So 16, 26, 50, 21.5, 40, 16, 19.6, and 19. All right. Doesn't matter if there's anything in the other tables or not. Let's start back over here with our hypotheses. First, we're going to start with H naught, which is that rho equals 0. There is no relationship. And the alternate is that rho does not equal 0, or that there is a relationship, a linear relationship between these. We are not going to make a claim here. We're just going to let the data tell us what there is. So the next thing I need to do is calculate my test value. So I'll go to stat, I'll run a calc, and it's option 4. I get negative 0.173. Now I need to know where my critical values are from table I. Now we're going to go ahead and use alpha at 0.05. And it looks like there's 1, 2, 3, 4, 5, 6, 7, 8 values. So n equals 8. We'll need that information when we come and look at our test statistic, our critical values. Okay, so we need to find table I. These are towards the back of the book. H is a long table. Here's I. Okay. So when we look at I, first the degrees of freedom is n minus 2, which means I need to go to 6. And then because I'm using an alpha at 0.05, I would use 0.707. That is going to be my cut value, or my critical value. So it'll be plus or minus 0.707. What that means is that if 0 is in the middle at 0.707 or at negative 0.707, that over here on the edges are those extremes that would tell us we do have a relationship here. We have to be pretty far out to claim a relationship. But with an R of negative 0.173, that R is not very extreme. So I would not reject H naught. And I would say that there is not a linear relationship. If I rejected H naught, I would say that there is a linear relationship and a model can be built. All right, guys, good luck. We'll see you in class.